Hello. Today we're going to be looking at section 9.2, which is about angles and radian measure. We have three goals for today. We want to be able to draw an angle in standard position, find coterminal angles, and convert angles between degrees and radians. So let's start with that first target. An angle in standard position will have a vertex at the origin, an initial side, on the positive x-axis, and a terminal side rotated specific angle measure. So we start with a set of axes. We put our vertex at the origin there. We put our initial side on the positive x-axis. And that's going to be a ray with an arrow at the end. And then our terminal side, we'll put it over here for this particular angle. I guess I can even label our vertex. And so this is the angle from here to here is represented in standard form with this diagram. A couple of notes. We will rotate up from the initial side. For positive angles. Or if you think about this as the old analog clocks, this would be counterclockwise. And our angle will rotate down from the initial side. For a negative angle. So for example, one, we're going to draw each angle in standard position. And first we'll do 230 degrees. Then we're going to do negative 160 degrees. And then our last one will be 690 degrees. Since this angle is positive, I know I'm going to be rotating up. I know my vertex will be at the origin. My initial side will be on that positive x-axis. If it helps you to add some additional labels, you can, right? We know a quarter of a turn around is going to be 90 degrees. Halfway around would be 180 degrees. 3/4 of a turn would be 270. All the way around would be 360 degrees. So to get to 230 degrees, right? Quarter of a turn is 90, halfway around is 180, 3/4 is too far, that would be 270, so 230 is going to be in between those. So you kind of have to estimate about how much it is. You do not need to measure it out with a protractor to figure out exactly, but you do need to have your terminal side in the correct quadrant and, closer to the appropriate axis. So 230 is a little bit closer to 270 than it is to 180. So maybe I'll draw it like this and then draw my little spiral to show which way I went around in the positive direction. Okay. All right, our next one, negative 160. Put my vertex on the origin, my initial side on the positive x-axis. This time I know I'm going to rotate down. I'm going to rotate clockwise. So here would be negative 90. This would be negative 180. This would be negative 270. So to get to negative 160, I have to go past negative 90. I don't want to go all the way to negative 180, so maybe we'll estimate that's about right here for my terminal side. And then put my little arrow there to show which way I rotated to get there. Finally, we have 690 degrees. Vertex at the origin. Initial side on the positive x-axis. Notice this time our angle is larger than 360, so we're going to be going more than one time around. Okay? It's positive, so I'm rotating up. So if I start from my positive x-axis, all the way around once would be 360. If I keep going another 90, here's 450. Keep going, here's 540. If I keep going, here we have 630. So 690 is going to be a little ways past that. So maybe about right here. Draw in my terminal side. Okay. So you'll see a spiral on these ones where we go more than one time around. And there's all those angles in standard position. Next definition for us today are coterminal angles. These are angles with the same initial and terminal sides, but different rotations to get there. So if you look at this previous diagram, okay, we could have gotten the same initial and terminal sides by starting here and just going around this one time. We could have also gotten this same initial and terminal sides by rotating in the negative direction from here to here. Or there's a whole lot of ways to get the same initial and terminal sides, right? Just by going around an additional time or additional 2 times or rotating the opposite direction. So there's an infinite number of coterminal angles for any given angle. In example 2, we're going to find one positive and one negative angle that is coterminal to the given angle. And we will look at negative 40 degrees, and then we'll look at 800 degrees. So since coterminal angles vary by different number of rotations, each rotation around a circle is 360 degrees. So to find our coterminal angles, we're going to add and subtract 360 degrees. So if I start at -40 and I add 360 to that, -40 plus 360 is 320 degrees. I feel like that's a little fuzzy. One more. There we go. If I do -40 minus 360, I'm going to get -400 degrees. Here we have a positive and a negative angle that is coterminal to our original angle of -40 degrees. Looking at our next example, 800 degrees. If I take 800 and add 360 to it, we're going to end up with 1160 degrees. So there's a positive angle that's coterminal. If I take 800 and subtract 360, let's see, 800 minus 300 is 500. 500 minus 60 would be 440 degrees. Ooh, I found another angle that's coterminal, but it's not negative. So I guess I'm going to have to keep going. So if I take 440 and subtract 360, we're going to have 80 degrees. Ooh, I'm still not to a negative angle. Guess we're going to subtract again. If we do 80 minus 360, we get, what's that, negative something. Negative 280. I should have known that. Oh well. Now I have a negative angle that's coterminal. Okay? So for your positive coterminal angle, you actually could have listed any of these. So if you recognize that your angle is going to take you more than one addition or more than one subtraction, don't feel like you have to do both things. I could have started by subtracting. Hey, there I have a positive angle. Subtracted again until I got to a negative angle. Okay? As long as you get one angle that's positive and one angle that's negative, that's going to be just fine. Okay? Next definition for us today. Radians are a unit for measuring angles. We're very familiar with using degrees to measure angles, but it's not the only unit, and for some purposes, particularly when we get to graphing in an upcoming section, radians are much more efficient for us to use when dealing with graphing. Okay? 1 radian is relate to using a circle. Okay? So radians measure angles in relationship to the length of the radius of the circle. Okay? So this angle here, if its arc is the same length as the radius of the circle, then that's 1 radian. 2 radians would have an arc whose length is the same as 2 radii of the circle. as a point of reference, 1 radian is about 57.3 degrees. You don't have to know that, but in case you were curious. Our big thing for today is that you need to be able to convert between degrees and radians. I'm going to turn my paper over for that. So to go from degrees to radians, you're going to multiply by pi radians over 180 degrees. And if we want to go from radians to degrees, we're going to multiply by the reciprocal of that, 180 degrees over pi radians. So in example 3, we're going to convert negative 150 degrees to radians. And I'm going to show you how to do this without a calculator and then how you can do it if you do happen to have a calculator. We're taking negative 150 degrees. We're going from degrees to radians. So we're going to multiply by pi over 180. And I'm going to abbreviate radians as RAD because radians are rad. Over that 180 degrees. If you have a hard time simplifying fractions, one strategy that you can use here is to break down these numbers into its prime factorization. So if I break down 150, 150 is what? 50 times 3, 50 is 5 times 10, 10 is 2 times 5. Okay? And I'm going to do the same thing with the 180. 180 is 30 times 6. 30 is 6 times 5. 6 is 2 times 3. So was this one. All right, so if I were to break this all the way down, you might also find it helpful to write that negative 150 as being negative 150 over 1. So on the top, we have negative. The 150 gave us a 2 times a 3 times a 5 times a 5. And we have times a pi. And on the bottom, from the 180, we have a 2 times a 2 times a 3 times a 3. And notice that, I should have done this first. Our degrees are going to cancel out because we have one on top and bottom. But now looking at this next step, well, I have a 2 on top and bottom, so it'll cancel out. I have a 3 on top and bottom, so it'll cancel out. All right. So now, if I just multiply out what's left, on top I have negative 5 times 5 is 25 times pi, so I have negative 25 pi. Over on the bottom, 2 times 3 is 6, so negative 25 pi over 6 radians would be my answer. If you have a calculator, like the ones that we do at school, I would start with my negative 150 and then multiply by, I'd have to use the fraction button, pi, and I'd have to arrow down over 180. There's my end parentheses, and if I hit enter, it tells me I should have negative 5 pi over 6, which tells me I made a mistake back here. So let's find my mistake. Oh, I forgot about this 5 right here. So if I add that 5 to the bottom, oops, then a 5 would cancel out from top and bottom, and we would just have negative 5 pi over 6. Okay. Nobody will know, except for everybody who watches this video will know. Oh, well. Last example for us. We're going to convert 9 pi over 5 radians to degrees. Okay. So our initial setup, we're going radians to degrees. So we take our radians, 9 pi over 5 radians, and we're going to multiply that by 180 degrees over pi. And notice right away that our radians are going to cancel out. If we break things down for ourselves a little bit to make it easier to simplify, if we don't have a calculator, 9 is the same as 3 times 3. 5. Our 180, we broke it down earlier, so I'm just going to take those again. So that was 2 times 2 times 3 times 3 times 5. I won't forget the 5 this time. Over pi. All right, and now we look for things that we can cancel out. Well, we have a pi on top and a pi on bottom, so those cancel out. We have a 5 on top and a 5 on bottom, so that cancels out. So we are left with 2 2s and 4 3s. And if you didn't have a calculator, we would just work our way through. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. And 108 times 3 is 324 degrees. If you had a calculator, clear out this last thing. So we had 9 pi over 5, and we're going to multiply that by 180 over pi. And if I hit enter, hey, there's our 324 degrees. Now on these problems, make sure that you label your answers with the degree symbol or the radian symbol, the appropriate unit for the problem that you're doing. That's all that we have for today. Good luck with your assignment. Please reach out if I can help you in any way.